This is 3.5c. I would suggest on the top of page 310 that you write the occurrence of lines as asymptotes of rational expressions down. I think I hit pretty much everything there. So those will help you to determine how to do the vertical, horizontal, and oblique asymptotes. And then that second box on page 310 is an outline of a procedure that we use to create accurate graphs of rational functions. So pretty much what we've already done, and we'll just kind of follow these steps. For example, 8 and 9, and then we've got 10, and then we'll be done with this lesson. So let's look at example 8. So let me kind of go over the 5 steps here. First step is to find the real zeros of the denominator. Okay, so that determines the domain, and it gives us a chance then to sketch the vertical asymptotes. 2 is find the horizontal or the oblique asymptote. If there is one, sketch it. 3 is find the zeros of the function. Find out where they cross the x-axis. Now they will cross the x-axis when the numerator is 0. Okay? Because anytime you have a numerator of 0, the answer is 0. And that's what we're looking at. When is y 0? So we're going to look for the numerator and make it equal to 0. Then we find f of 0, and that tells us where it crosses the y-axis. And then we just kind of find a bunch of other numbers and plug in there to kind of get the general shape of the graph. All right, so let's start with step 1. Step 1 says find the real zeros of the denominator. Okay, so we're going to look at 3x squared plus 7x minus 6 equals 0. So we're going to find out what makes that denominator 0, because that is going to be the x values that are not going to work. So when you do your math and your grouping and factoring and all that fancy schmancy stuff, you're going to get, let's see, 2/3 and -3. So those are your asymptotes. So let's go ahead and draw those. There's my -3, and then I'm going to be at 2/3. Okay, so vertical asymptotes are done. All right, so step 1 is complete. Let's jump to step number 2. Because the degree of the numerator is less than the degree of the denominator, y equals 0 is the horizontal asymptote. Because this is a 1 and this is a 2, my horizontal asymptote is 0. Yay, that means I don't have to worry about the oblique asymptote because I do have a horizontal asymptote. Okay, step 2 is done. All right, let's look at step 3. Oh, it doesn't look like a 3. Oh well. Step 3 says find the zeros of the function. So we're going to find the zeros of the numerator. So you just set it equal to 0. Okay, so we know this crosses at -3/2, 0. So -1.5, 0. We cross the x-axis right there. Good to know. And it only crosses at one place. Okay, so notice, remember what I said is about the horizontal asymptote? The vertical asymptotes, the lines never cross. The horizontal asymptote usually doesn't, but can. And in this case, it crosses the x-axis right there. And since that's the horizontal asymptote, this is one of those times where the graph is going to cross the x-axis. Okay, so once we get to step 3, step 4, we're going to find the y-intercept. And the way we do that is pretty simple. We put in a 0 for every x, whoops, every x that we see. So that gives me 3 over negative 6, or negative 1/2. So we're crossing the y-axis at negative 1/2. Okay? So those were our 4 steps. And really, all we did is found pretty much 2 points. Alright, so now what we're going to do is we're going to make our handy-dandy little XY, plug in a bunch of numbers, and see what happens to this graph. And when it's all said and done, we're going to get a graph that looks like this. Okay? So yeah, you're going to have to put in a couple numbers over on this side, a couple numbers over on this side, and a couple numbers in the between here to kind of get an idea of what this graph is going to do, and that's going to end up being what it looks like. Okay, let's do one more of these. Alright, so step 1 is what makes this denominator 0. Okay, when we break that up into terms, we set this equal to 0, and we get an x plus 3 and an x minus 2. So we know it's going to cross the x-axis at negative 3, or I'm sorry, the vertical asymptote is going to be negative 3 and positive 2. Alright, so then we're going to find out if we have a horizontal asymptote, and our numbers are the same, and so this and this is going to be 1 over 1, so our horizontal asymptote is going to be at the number 1, which means because we have a horizontal asymptote, we don't have a slant asymptote, which is always good. Alright, step number 3. We find the zeros of the numerator. Those plus or minus 1. So I know I'm going to cross the x-axis at negative 1 and positive 1. Okay, that's what that helped me find. And that was what? The third part of that. Fourth part is put 0 in for everything. So it crosses the y-axis at 1/6. Ooh, that's going to be a little hard to draw, but kind of pretend that it's there. And then we find other points to get our drawing. And we end up with, again, another drawing that kind of does this, kind of does that, and then does that there. Okay, so this one is going to be a little bit different, and so let's go ahead and factor x plus 1 and x minus 2. Alright, so my domain, or my what x cannot equal, is negative 1 and 2. So what happens then is you would automatically put in a negative 1 for this vertical asymptote, and then you would go and put in 2 as your other vertical asymptote. And this is the little tricky part that they put in here. If this number here will make this 0, so give you a vertical asymptote, but it will also make the numerator 0 as well, then it is not a vertical asymptote. Okay? So again, if one of the numbers that you find is a vertical asymptote also makes the numerator 0, then you cancel it and don't use it as a vertical asymptote. Okay? Really not going to go into why that is. We're in 10 minutes here. Doesn't really matter at this point. Just remember that if the number makes the top 0 and the bottom 0, then it doesn't count. All right, so the degree of the numerator is less than the degree of the denominator, so y is 0. Okay. Let's see. There are no zeros of the function and thus no x-intercepts. Okay. Because 2 is the only 0 of the numerator and 2 is not in the domain of the function. Okay. Because we just threw it out. So we cannot put a 2 in here to make that equal to 0. So this graph then will not cross the x-axis. All right, so what about where it crosses the y-axis? G of 0 equals 0 minus 2 over, and when you do this, you just get a negative 2, so you end up with 1. So it crosses the x-axis, or the y-axis at 1. That's really about the only point we have so far, isn't it? So the graph of g of x is the graph of y equals that, and the reason for that is let's look at all of this and rewrite it as g of x equals x minus 2 over x plus 1 x minus 2. See what happens here? That cancels with that, and we end up with 1 over x plus 1, which is what I suggested that we were going to get there. Okay. So we draw the graph indicating that there's a hole, and there is a hole at 2. So when we draw this, when we get to x equals 2, we have a hole here because 2 does not work up here. Okay? 2 is not a solution. 2 makes this undefined. So the graph goes around, does not cross the x-axis, got a vertical asymptote here, but because of this 2 right here, we have a hole. And that hole ends up being at, well, 1 over 2 plus 1 equals 1/3. That's our y value. So at 2 1/3, we have a hole. Okay? Really kind of iffy as far as how in the world do you make that determination. Okay. When the numerator and the denominator have the same factors, this has an x minus 2, this has an x minus 2, whatever makes this 0, 2, also makes this 0. So therefore, you do not count this 2 here as a vertical asymptote, so you can only use this one. When these two cancel, you're left with a 1 over x plus 1 here, okay, because these naturally will cancel. And then where the hole is going to be where this number that made this 0, this 2, is in here, and 1 over 2 plus 1 is 1/3. So that gives you your hole right there. And then everything else in the graph is the exact same. All right, so that's it for 3.5.